Hello and welcome to WhoKnowsThisStuff.com. It's a beautiful sunny day, so guess what we're going to be talking about today? That's right, you guessed it, solar. We're here in Menominee, Wisconsin, and we're going to be visiting with a small company called Bubbling Springs Solar. Now, Bubbling Springs Solar is a small manufacturing company. Mike and Louisa are going to take us through the process of how they came about. We're also going to be talking about a very unique relationship that they had with the University of Wisconsin Stout campus and how the University of Wisconsin Stout campus was able to help them develop their business in providing encouragement, providing facilities. It's really going to be a great story. Let's go along and visit with Mike and Louisa and learn more about Bubbling Springs Solar and what they do.
Mike got interested in the idea of putting together a better solar thermal collector while taking apart an older one, not ours. Probably what, a 1974 model at the farm, and he and my mom's husband were trying to fix something and get it back up on a roof and running. And in frustration, like many people, when you're trying to fix something, you think, God, just start over. This is crazy.
You know, starting a manufacturing business, small, you know, kind of low budget startup, it's tough, and there isn't a lot of there's not a lot of that happening. Hopefully there's more of it happening now, but it's kind of a barren landscape out there, and to find someplace like the University of Wisconsin Stout that's willing to support and to encourage and even provide low-cost facility to operate out of.
That was huge.
That made a world of difference, yeah.
They were looking for somebody to fill their space that they had in manufacturing and technology. They had an incubator spot that had been empty for a while. We were looking to rent a place to move out of our prototyping tiny shop into a production facility. People often ask how we got our name. We were looking for various names. We needed a web name to go with it. Everything we wanted.
Hours trying to find just the right name.
Very frustrating.
Yeah, and all the good ones were taken. Finally, in sort of frustration, we said, let's just call it Bubbling Springs Solar.
Yep.
And everybody said, hey, that's a great name.
So
after all that effort.
I think it's a silly name, but we like it. And you know, at the beginning there in the 2000s, we were just getting into the local movement, and naming it after the place that it started seemed to be somewhat appropriate. So the first year we got certified at the very last quarter of 2008. We sold 37 collectors that year. 2009, we were almost up to 300 collectors, and we were hoping this year to
double that. All right, what we're looking at here is the absorber plate that is the internal working component of the collector. This is where the rubber hits the road, the sun shines on this plate and heats the fluid that's being circulated through the copper piping. There's a header pipe on each end, then they're joined with the 8 riser tubes that are running the length of the collector. There's an aluminum fin that's bonded to that copper piping, and once this absorber plate is assembled into the collector itself, it gets its black absorptive coating applied to it. So this is the absorber plate. It's been assembled earlier, made up of the header pipes and the riser tubes with the absorber fin bonded to the risers. Right now we're assembling our MS32, which is a 4 foot by 8 foot size collector, 32 square feet. We also have a 4 by 10 collector that's 40 square feet. We offer the 1-inch header, which is what we've got here, and we also do a 3/4 inch header for smaller system collector arrays. This is a fiberglass fabric that we put in basically for aesthetics. The insulation we use is yellow, so we're hiding the yellow insulation with this black fiberglass fabric. Now this is a compressed fiberglass. We like it because it will last nearly forever. Heat is unaffected by heat, and these collectors can get into the 350-degree range when they're stagnating, which is, you know, sitting in the sun without fluid circulating through them. And so we wanted an insulation that would hold up well over long periods of time to those high temperature situations. The insulating value of this insulation is adequate to get the high performance that we're looking for. Increasing the R value really doesn't benefit the collector that much. One of the reasons for that is that there's air vents that allow air to circulate through the collector to keep moisture from building up, which was a problem with a lot of collectors in the past. This step is just putting those breathing vents that I just talked about. We're cutting a hole through the insulation to allow air to move. We're going to actually cut, when we put the back sheet in, we'll put vent holes that line up with these openings. And again, that allows air to circulate through the collector and prevent any moisture from building up in the collector. All right, we're fitting the aluminum back sheet into the collector. As you can see, we put it together kind of upside down, and sometimes this goes real nice, and sometimes it takes a little. So this is the perimeter insulation that we're putting around the back and the side, or the sides, ends and the sides, I guess. As you can see, pretty much everything in our shop is hands-on. I was thinking about this, and I think the only robot we have is our coffee maker. So this is the low iron tempered glass that we glaze the collectors with. In addition to those two factors, the low iron content and the tempered strength, it also has a prismic texturing on the inner surface to diffuse the light and give it a more frosted, sort of smoky glass look that improves the aesthetics. Basically, it doesn't affect the performance. The inner surface that we just washed, so we're going to put that face down on the collector here. This glass is very durable, but somewhat fragile on its edges. Now Doug is going to install the glazing gasket, which is a U-shaped EPDM rubber gasket that goes completely around the perimeter of the glass. So now we're installing the capping strip that holds the glazing onto the collector. So that is it. Finished product. Okay, so we're looking here at a mock-up of a closed-loop glycol solar domestic water heating system. These are our thermal collectors you see here, the 3 panels. They're a scaled-down version of our full-size collectors. And the solar photovoltaic panel provides power to the circulating pump that's circulating the fluid through the collectors where they gain heat, obviously. And then that heated fluid is then circulated through a heat exchanger coil in the tank in this case. And then it's returned back to the collector array for additional heating. On a home, this tank would feed into your conventional hot water heater or a demand type hot water heater as a backup source for heat when the sun isn't able to bring the temperature all the way up to usable temperature. So.
Well, we're glad you came out today. We were really happy to host you. Who knows this stuff? It's one of those questions, isn't it?
It is.
And
now,
now,
important question.
We hope you know a little bit more about how to make a solar thermal collector, how we make them here at Bubbling Springs Solar. If you'd like to know more about our company, we hope you'll visit our website,
which is www.bubblingspringssolar.com.
And thanks for coming out to visit us here in Menominee, Wisconsin. We were really happy to host you. Thanks for coming.
Thanks a lot.